Next, we're going to look at reacting a secondary amine with an aldehyde or ketone. And in a secondary amine, the nitrogen is bonded to 2 carbon atoms. Again, this uses trace acid, and it's going to be similar mechanistically to using the primary amine. The problem is, when we used a primary amine, there was 2 hydrogen that ended up getting removed during the mechanism. Because secondary amines only contain 1 hydrogen, the mechanism is going to change a little bit toward the end. So here's the product for this reaction. We end up forming a bond where the carbonyl was to the nitrogen. And that nitrogen will still have its 2 methyl groups. But we also end up getting a double bond right here. So where the carbonyl carbon was and the neighboring carbon, you end up forming a double bond. This particular functional group is called an enamine. The ene for the alkene, the amine for the amine. The byproduct of this is, again, water. Let's go through the reaction mechanism. First step, we're going to use the acid and protonate the carbonyl. So this is identical to what we did with the primary amine. The next step, still nothing new. We're going to use our amine. And I'm going to take its lone pair and add it to the carbonyl carbon and push these electrons up to the oxygen. Okay, so now we have the protonated nitrogen. We want to get the proton onto the oxygen so we can get rid of it as a leaving group. So again, same thing as we did in the previous reaction. We're going to do a proton transfer. Okay, now we have water attached, which is a good leaving group, and we'll use the lone pair on the nitrogen to assist it in leaving. So I'll push this lone pair down to form a pi bond, and that helps push the water off of the molecule. Okay, to this point, everything has been identical to the amine formation that we did with a primary amine. But the difference now is there's no hydrogen on this nitrogen to take off to leave us with the amine. But we need to get to a final neutral product, and the way that happens is we still do a final reaction with a base, just a weak base in the solution, anything with a lone pair. But what it will do instead is react with one of these neighboring protons. So I'll draw one in. That base can come and take this proton. That will push these electrons over to form the pi bond and push these electrons up onto the nitrogen. So now we're left with our neutral enamine product and, of course, the protonated base. Now you'll notice that I happen to choose a proton on this left side, which put the double bond on the left as opposed to the right. In this case, it doesn't matter. This ring is symmetrical, so these two products are identical. But we are going to look at what happens when you have an unsymmetric ketone, and in that case, you're going to have to consider both sides and draw 2 different products. In this particular case, we're starting with an unsymmetrical ketone. When we do this problem, what you really need to do is draw your iminium ion intermediate. So you can go through all the mechanistic steps if you want, but eventually you're going to get to this structure. We're going to have the double bond to the nitrogen, and in this case the nitrogen has a ring and a positive charge. Now what you want to do is identify the carbon where the double bond is at, and then look at neighboring carbons. These neighboring carbons is where the elimination will occur from. So you want to find if those carbons have hydrogens, and both do. The one on the left has 2 hydrogen. We're going to draw in 1. The one on the right has 3 hydrogen. Again, I'm just going to draw in 1. Okay, so let's label these proton type A, proton type B, and we'll go through the pathways for each. So if we eliminate through A, and I use a base, we'll take this proton, eliminate to give the double bond, and push those electrons up onto the nitrogen. So then our final product, we will have the double bond on the left, and then attached here, the cyclic amine. Now if we go through by proton B, again we'll use a base. That will come and take this proton, eliminate, and push those electrons onto the nitrogen. So in this case, the double bond will be on the right side, and there's our cyclic amine. So both of these products will result in this particular reaction.